Hopefully you found the spot to come back to this. I should have prefaced that in the directions it does state for polynomials you'll have a degree in leading coefficient. And in C, that's not a polynomial function. Exponentials are not polynomials, so we don't talk about the degree in the leading coefficient since the degree an exponent itself is x. So we actually don't talk about that in C. It is an exponential, and you can still talk about the end behavior. It just changes a little bit because as you go left on the graph for negative infinity, it's always going to just approach 0, so that's a little different of a case. And then as the graph goes to positive infinity, so as the graph goes right, it does go up, so you would have an infinity sign. But that's just a special case when something is a non-polynomial. But D, E, and F you could figure out based off of the arrows on the end. So check those over. Make sure to ask a neighbor if you have questions on them. And once you know end behavior, that's going to help us actually create the graph. So now we're going to take that end behavior and take everything that we've done and put it together in a sketch. And it's kind of like a step process. So in the first two questions, I gave you the steps, and then in the practice questions, you kind of just need to do it all yourself. Okay, so you always need to ask yourself when you're making a sketch, what is the degree of the function? Okay, remember that it's all the exponents added together, so our 1 and 2 makes the degree of 3. A leading coefficient would be if there is a number in front in factored form. Okay, in factored form, you would have like an a value, or if there's any a's that you would multiply together in front of any x's. So if you have any coefficients of x's, you can multiply them together. So here we just have a positive. Okay, our end behavior. So since, this is where you kind of think about what your arrows are going to look like. So since I have a positive leading coefficient, my right side goes up, so that means I have a positive infinity. And then since the degree is 3, I have to be the opposite of this. So I have to go down and I have to have negative infinity. So right side up, left side down. So I actually kind of make those markings on my graph down below just so I remind myself that that's what should match. Okay, so on the right side, because it's a leading coefficient, it's positive, it goes up. On the left side, because the degree is odd, it's opposite. Then you have to figure out where your x and y intercepts are going to go. Those are really the only things that you are required to put on your graph, x and y intercepts. So your zeros that are real, I'll put that here, your real zeros. So my real zeros are positive 3 and negative 1. And then you have to remind yourself about multiplicity. So there is none on 3, so that's just going to go straight through. But on negative 1, there's a 2, so that means that there should be a bounce. Okay, because remember, it's an even multiplicity, so anytime you have an even, it's a bounce. Then you have to calculate the y-intercept. So y-intercepts you substitute in 0. So when I put in 0 for x in both sets of parentheses, 0 minus 3 is just going to give me with negative 3. 0 plus 1 is going to give me a 1, and then I still have the exponent that's squared. So really, you're just putting zeros in both of these x spots. So the x's kind of just go away when you calculate your y-intercept. And so negative 3 times 1 is negative 3. So these are the things I have to put on my graph. I have to put a y-intercept at negative 3, an x-intercept at positive 3, and an x-intercept at negative 1. Then you just have to connect everything, but making sure to include the bounces and the twists. So I'm going to start with my left arrow that I already put there, and it just goes, it does have to bounce at that negative 1. So bouncing means goes up to it and comes back down to go through the y-intercept, and then it goes straight through the x-intercept of 3. So that is all I expect you to do. X-intercepts, y-intercepts, and arrows with your bounces and twists. Okay, I'll explain one more, and then you're going to pause this to try the next 4 on your own. Okay, so in this one, my degree is 4, since my exponents add together to 4. Again, there is no number in front, so it is a positive 1. Okay, So that means positive right side, even same side. So both of my arrows are going to go up this time. Okay, so meaning that both of my end behaviors are positive infinity. I have a real 0 at positive 3 with no multiplicity. And I have a 0 at negative 1. This time it's odd, so it's going to be a twist because of that 3. So once again, for y-intercept, negative 3 to the first power, 1 to the third power. My y-intercept is again negative 3. That's just a coincidence. When I multiply those things together, so I have to put 1, 2, 3, 1, 2, 3, 1, making sure to twist through the negative 1. So twists don't have to be pretty, but as long as it's obvious that it's a twist and not a straight through. So I kind of make it curve right before I go through it to show that it's a twist. Okay, so I would like for you to pause this video and try these next 4 graphs on your own. Going through the same process I did, you do not need to write everything down. You just need to write where your arrows are going to go, your x-intercepts, and your y-intercepts.